So here we go. Let me just go ahead. And it was 15. Okay, so that's 2 pages after that. All right, so let's see if this is it. Oh, well. Okay, yeah, here we go. I just like using graph paper just because I think it's easier. So here we go. So I'm going to paste. Going slow today, sorry guys. All right, so here we go. So let's just go ahead and make a graph. Okay, so -4, 8. One, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Somewhere around there. -1, 1, 2, 3, 4, 5. Okay, now this one's nice too because 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now I remember talking, Simon, I think you were up here asking me and someone else was asking me too. So I think this is a real good problem. So let's go ahead and do this. Let's draw the triangle. Okay, so now some of you, it was easy because, or not easy, but there is this horizontal line, right? So this is a horizontal line. So the only thing that can be perpendicular to that is the what? Vertical line, right? But it's got to be coming from this vertex. So you have to recall that you can have an altitude that is outside the triangle. All right. So what happens now is you would extend this base over, and then this is the actual height of that triangle. Everybody see that? All right. So now I'm going to try to find, for example, now I want to look at this and I'm going to find the altitude to that. Right, in order to find the altitude, I want you to realize that I'm supposed to be coming from this vertex. So from this vertex, I have to draw the altitude. Well, the altitude or the height is going to be perpendicular to the opposite side, which means I have to know the slope of that line or that segment. And what is the slope of that segment? Is that right? Is everybody agreed? -1/3? So that slope is -1/3. So then I want you to tell me the slope of the perpendicular would be what? 3. All right, so what I'm going to do is from this point, from the vertex, I'm going to go up 3 and over 1. Up 3, 1, 2, 3, and over 1. That's the perpendicular. So now watch. That's perpendicular through that point. Well, I don't see an intersection point, correct? That's because I didn't extend it far enough. So the orthocenter is actually what? It's actually, it's actually outside probably right then. All right, so how did I find that? Up 3 over 1 is the same as down 3 left 1. So let me show you what I'm doing. I'm gonna make it a little bit bigger so we can see. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. So now from the red line here, I now found the orthocenter. This is the actual orthocenter down here. Okay? So does that make sense? Now notice these are easier because they always line up perfectly. All right, so again, I really and truly don't feel like that's all that important. All right, I just don't feel it's that important. All right, so on the test, if I ask you to draw the orthocenter, you probably do it on graph paper and you probably be able to figure it out. If we wanted to, we could graph this line right here. So I want everybody just to review this with me because I think understanding lines is much more important. I think that's the purpose of this lesson, all right, even though we didn't have to use it. All right, so I want someone to tell me what the equation of this line is right here, this highlighted yellow that I'm doing. What is that? No, I'm asking you for the equation. Well, no. A vertical line is always x equals. So the equation of this line right here is just x equals what? X equals -4, which makes the problem easy. What's the matter, Sam?
Well, how do you know what vertex, like, which was, how do you know what?
I know what you're saying, so listen. From the vertex, you have to draw a perpendicular to the opposite side. Right? So from this point, now please watch. I'm gonna make a thick line so you can see it, but it's gonna be not as easy because it's thicker, but I want you to understand what I'm saying. So this right here, I'm gonna do purple. So from here, I'm supposed to draw a perpendicular over here somewhere. There is no perpendicular over here. Can you see, visualize that, right? So the perpendicular has to be extended to here. You with me now, right? Now that you understand that, what I'm going to do is from this point, I have to be perpendicular somewhere along this. Well, there it is right there. True? Now, if I'm going from this point right here, if I'm trying to draw the perpendicular, is the perpendicular there? No, it's got to be where? On the outside, right? And it's got to be perpendicular. And it just so happens that this perpendicular will be about right there. Now, how did I know it was right there? That's where the orthocenter is. Now watch me. I'm going to extend that green line, not as thick. I'm going to extend this green line right there. And what do you know? It's perpendicular. You with me? So you're always going from a vertex to an opposite side. That's what we're trying to look at. And a lot of times you can just eyeball it because you're pretty good at seeing a 90-degree angle. All right? So what, Morty? Yes, exactly. Because if you're going to draw something that's perpendicular, the slopes are negative reciprocals. Right? So now I'm back to my equation. So look, guys, please listen to what I'm saying. All right, you write equations of lines all the way through calculus. Every math class, you're going to have to write equation of line. It's embarrassing. All right, we've been doing it since, 7th grade, and you should just know it now. All right, so I'm asking for the equation of this, not that line, but I am asking for the equation of this line right there. So what did I say the slope of that line was? 3. We said the slope of that line was 3, and it's passing through what point? Negative 1, 5. So now I want to write the equation with this slope and this point. Go. Y minus 5 equals times. Beautiful. Now that's that equation. And then the other equation is x equals negative 4. I need to find where those lines intersect. What? How did I know to use this purple line right here that I'm pointing to? Well, because I'm trying to find the orthocenter, right? The orthocenter is this point right here. That's on that line. Yeah, good questions. Now, come on, I mean it. Listen, some of you don't know because you don't ask. That's the problem. You don't know because you don't ask. All right? That should be perfectly clear for everybody. I just drew two lines. I'm trying to find the equation of both lines so I can find where those two equations intersect. Now, if you don't know, now's the time to speak up. These are the two equations, right? Of both of those lines. I'm trying to find this point right here. We know the x-coordinate because the x-coordinate is always what? Negative 4. So how do I find the y? Plug in negative 4 for x. And that should just be mental math. Negative 4 plus 1 is what? Negative 3 times 3. Negative 9 plus 5. So the y value should be negative 4. And what do you know? What is that point? That's the orthocenter, negative 4, negative 4.
Mr. Shaw?
Yes, sir.
Could you have used a different line if it still passed through a different point?
Brilliant. Yes. You have to pick 2 out of the 3. That's how you find. Do I need the third line? No, because we don't make mistakes. So we just need 2 lines. If you thought you made a mistake, you should do what? All 3 lines. All right, so you are 100% right. We use the easy one though. And x equals negative 4 was the easiest one because it was a vertical line. Because it was a vertical line. All right, now listen guys, I'm not making a big deal of this because I don't think it's that important. But what is important is being able to draw and to write the equation of the lines. I really am not a big fan of finding the orthocenter and finding the end center and all that stuff. All right. So on your test, when you have to do this, I'm going to let you graph them and find them graphically. All right. But to me, you know, if the intersection point was in the middle, we wouldn't be able to tell what it was unless we wrote the equations of the lines. All right. Now, again, hopefully that people are understanding now. All right. I really appreciate that question. All right. And like I said, you know, I appreciate some of you asking questions and some of you sitting there not willing to ask the question is frustrating if you don't know. Now, if you look at that right there, I say that looks complicated. All right. For an average person, they're going, oh my gosh, you guys are really smart. But I'm trying to convince you it's not difficult at all. It's simple, simple, simple stuff. All right, but if you're just following along, when you have to do it yourself, it's not going to be simple. What? You got to speak up. So, I'm sorry. Yes, yes, exactly, exactly. And why did I do the vertical line? Because it was the what? It was the easiest. True. I always do these just like the one before there was a horizontal line and we just drew that one yesterday because it was the easiest one, right? Because it's always x equals or if it's a horizontal y equals and I already have one of my answers, right? So we always try to find the easiest ones, all right? All right, guys, I appreciate that very much. That was a good job, I feel like. Hopefully you feel better, all right? Hopefully you feel better, all right? Now, let's just summarize a few things here real quick. All right, and because today's lesson's super easy, it'd probably take me 5 minutes. All right, well, a little bit longer than that, but okay. So yesterday we had or the day before, we had the circumcenter. I want you to write that down. Then I want you to write the end center. Then I want you to write the centroid. And then I want you to write Orthocenter. And now you should be able to tell me a little bit about all 4 of those. All right, so I need a volunteer for circumcenter. Who remembers the circumcenter? Tell me. You are awesome. Perpendicular bisectors. That's the perpendicular bisectors. All right. And perpendicular bisectors allow you to find a point that is what? Equidistant. Thank you. Equidistant from the what? From the angles. All right. Or we can say from the vertices. All right. Perpendicular bisectors allows you to find the point that is equidistant from the vertices. The end center, someone else, volunteer for end center. Tell me, Sam. That is correct. The end center is the angle bisector. Thank you. Wow. Very good. It is a point that is equidistant from the sides of triangle. All right, that's important, guys. All right, now remember, I'm just summarizing because it's one more day. All right, I don't like to memorize things. All right, but that's something you have to be able to tell me. You have to be able to reproduce. All right, centroid was what? Who remembers what that was? Yeah, centroid was the 3 medians. All right, and the 3 medians, which I almost forgot to tell you, was what's special about the centroid. Yeah, there's a formula for finding the centroid, which was the average. I'm not arguing with that, but I also forgot to tell you this. I remember saying, oh my gosh, I almost forgot. What was nice about the centroid? Oh, yeah, very good. All right, I like that. Divides the triangle into 6 triangles with what? With equal areas. But the other part of it was, yay, center of mass. So if you wanted to balance something that's triangular in shape, you could find the centroid, and then you could put that on a stand through that point, and it would balance itself perfectly. All right, so the centroid is the center of mass, divides the triangle into 6 congruent or 6 equal areas. And then the centroid does what to the median? Cuts it into what? 2/3, right. So the point, the centroid to the side, I want you to know is what? No. Well, I want you, yeah, that's the way the book described it. I don't like that. I say from the point to the side is what, Karina, do you remember? X. And from the point to the vertex is, and then the median is, that's how I want you to think about it. All right. So the median, all right, if that's the centroid, that's X, 2X, and this guy, the median is 3X. All right. And then, of course, the orthocenter is the what? Yeah, 3 altitudes. 3 altitudes, we also call them the heights, all right? And again, I've tried to do some research on Ortho Center. I see nothing like, wow, that's cool. All right. And then if I took, who remembers this now? If I took a triangle and I found all 4 points of concurrency, what is that called?
I remember, I don't think it was called that. Maybe they're like all on the same line.
They are all in the same line. And who is famous for finding that?
Oh, Euler.
Yes. All right. It's called Euler's, I think is what it's called. All right. Euler's line. All right. All of those points line up, or I should say are all collinear. All right. It's kind of weird, actually. I don't even remember the proof behind it, to be honest. But this guy has his own number named after him. It's called E. All right. Very famous. Yes. Tell me. Say it again. The height. It's also called the height. All right. The altitude and the height. I think the difference is, believe it or not, the height is the measurement and the altitude is the actual segment. All right. But big deal. All right. So those are the things. That's a good summary of those first 2 sections, guys. I think we're going to have one more test on Wednesday, all right, depending on how much we get done, all right? So again, I want to give you an opportunity, some of you guys that are super close one way or the other, all right? So again, very good. All right, so now what I want to do is download section 5.3 real quick, all right? This is the easiest thing in the world today, all right? I think this is the easiest thing we've done, all right? And again, this is very beneficial on standardized tests. All right, because the people who write tests aren't very good at geometry, all right? So if you remember these couple rules here, it'll be able to save you a lot of time on some of the standardized tests. All right, now once again, to me, all right, the exterior angle theorem was again something that was obvious, all right? So I want someone to tell me what the measure of angle 1 is equal to here. What does measure of angle 1 equal? You are amazing. Angle A plus angle B. So angle 1 is the sum of angle A and angle B, correct? So now watch how important this is. It's called the exterior angle inequality theorem. It's saying that the exterior angle is greater than the interior angles. All right. Now, it's not saying all interior angles, it's saying the remote interior. All right. Now, here, I want everybody to listen to me because this messes people up all the time. Is BCD greater than ACB? We don't know.
I say no.
We really don't know, right? Because I could make the exterior angle like this, guys. Uh-oh. Watch me, please. This, just give me a second. This could have been over here, right? I could have called this B. This could be the triangle. Does everybody see what I'm saying? This exterior angle now is not greater than this angle, right? So by looking at the picture, if I said, according to the picture, is BCD greater than BCA? Yeah, just by looking at it, you would say yes. All right, but we haven't measured it, so we don't know. All right, but what we do know is that every single exterior angle is greater than the remote interior. Is everybody with me on that? I cannot make any conclusions about these 2 angles. They could even be equal, right? If it was a 90-degree angle. But for sure, we always know that angle 1 is greater than angle A and angle B, right? Because the whole cannot be less than the parts. Does everybody understand what I'm saying? That's what we used to call it. The whole is greater than the what? The parts. The part cannot be greater than the whole. Do you understand that? That's simple. Super simple. What? Yes. No. Angle 1 is equal to angle A plus angle B. So let's say, for example, angle 1 was 100 degrees. That could be 80 and 20, right?
Yeah.
This is greater than this, and this is greater than this.
Oh,
That's what they're telling you.
okay.
All right, that's it. Simple. Obvious, right? Everybody should say that's just so obvious, right? So now let's look at the question. Measures that are less than angle 1. What is less than angle 1? Angle 3 and angle 4. Come on, that's super easy, right? Come on now. Anybody have any questions with that? What?
What about angle 5?
We can't know. We don't. I haven't told you any measure. The only thing I know for certain is angle 1 is greater than angle 3 and angle 4. I'm sorry, angle 3 and angle 4 are less than angle 1. I would say looking at it, angle 1 is less than angle 5. But it doesn't have to be. You understand what I'm saying? It's just the way they drew the figure. Right? Because watch me. I could put L over here and redraw it like this. And now angle 1 would be bigger than angle 5. Am I making myself clear? Right? You just want to know something for sure. All right? So basically, this is an exterior. It's always greater than the remote interior. All right, let's see if I'm making sense. So let's look at angle. What measures are greater than angle 3? Angle 5 and angle what? Why are we saying 2? Again, I'm not making myself clear, so I'm trying my best. Here we go. Yes, angle 2, just looking at it, if you had to look at it, you could say angle 2 is bigger than angle 3. But if I did what? If I move this over more this way, I can make angle 3 bigger than angle 2. You agree with me? Some of you guys are fixated on looking at the angle. You're not caring what the measure of the angle is. You are looking if it's an exterior or it's a remote interior. So let me say this one more time. Angle 3 is a remote interior for angle 5. Do you agree? Angle 5 for sure is greater than angle 3. Angle 3 and angle 4 are remote to angle 1. Therefore, angle 1 is greater than angle 3. I'm agreeing, guys, that 2 looks bigger than 3. But there's no rule that says adjacent angles, 1 is always greater. I hope I'm clear. All right, let's try 3. What measures are less than angle 1? Well, I don't know what you guys are doing. I'm a miserable failure.
Oh, 3
Hold on a second. Now look, this is, sorry guys, that was my own fault this time. I was continuously looking here. But now you have to look here. What is this? Yeah, I know. I'm seeing you now, but I wasn't paying attention before, so I'm telling you. That's 3 through 8, so just make sure you're making that note. All right, is everybody good? All right, and then 9 and 10, just to make sure. All right, so here we go. Measures that are less than angle 1. I'm agreeing with 5. and I'm agreeing with 6. So here's angle 1. That's, now remember, this right here doesn't have to be there, right? So if I covered that up, now you can see how 1 is greater than 5 or 6, right? All right, so now I'm going to erase that. All right, and see if there's anything else. Measures that are less than angle 1. Anything?
Maybe 4.
Say what?
Maybe 4.
Yeah, but again, that's good, but these are referred to as adjacent angles, or we could say they are supplementary. Does the exterior angle have to be greater than angle 4? No, because again, Harris, please, and again, every year I have to explain this, so it's good. This right here could be like this, right? So then the exterior angle, angle 1, would be less than angle 4. You agree with me, Harris, on that?
Oh, that was Zadok, but
Oh, I'm sorry. I'm sorry. Do you understand that, Zayden? You understand what I'm saying now? This and this right here, there's no comparison. Angle 1 could be equal to angle 4. Angle 1 could be greater or it could be less. There's no rule that says anything about supplementary angles, one being larger than the other. Is that good now? All right, let's try the next one. What measures are greater than angle 1? I like angle 7. Anything else? No, I don't think anything else. What? Come on.
So you don't share, right?
That I only know for certain. I only want to know for certain. That's what you guys are not understanding.
If you can change it, then
Regardless of how you change it, angle 7 will always be greater than angle 1, regardless. That's what I'm trying to tell you. That's exactly the way you should be thinking about it. You can change it, the figure, any way you would like. All right. Now, what angles are less than angle 7? Tell me, AC. That's what I like. Angle 1, angle 3, angle 5, and angle 6. Now, before you tell me something, all right, before you tell me something, double check. All right, what? Because look what you're not understanding. Watch me draw this. Shh, just watch me. If I get rid of that line right there, yep, that's the hardest thing. All right, that's the hardest. And again, on the test, that's what you have to visualize. You have to see all possibilities. And that extra line there is annoying. All right, so if I put that back and now I eliminate this, now you can see. All right, good job. All right, let's figure out the measures that are greater than angle 2. I'm saying angle 4. Somebody said angle 4. Can anybody say something else? Because 4 is the exterior angle, correct? Now, some people want to say 7, but I'm going to say there's no relationship between 7 and 2 except that they add up to 180. What? Yes, very important. Look at it. Measures that are greater than angle 5. Yay, I think we're getting it now. Angle 1 and angle 7. Everybody okay with that? And then what angles are less than 4? Yeah, angle 2 and angle 3. Yeah, guys, I just think that's easy. All right, now let's look at number 9. Come on now, everybody, think about it. This is a nice problem here. What measures are less than angle 1? Hold on a second. What angles? Bless you. What I'm going to do is I'm going to grab this real quick because I don't like it right over there. Copy, paste image. I'm going to blow it up so we can see it better. All right, here we go. Here is angle 1. Come on now. Angle 7, angle 5, angle 4.
What about 6?
I don't care about that. Look and hear me. This is the exterior angle. Those are the remote interior, right? You agree? Angle 7, angle 5, angle 4, and angle, no. An angle, you're missing one. Stop.
3.
Yeah, let's just say 1 through 8.
1, 2, 3, 4, 5, 6, 7.
Ooh, wow. Chuck is in the house, man. Angle P is correct.
What about N then?
All right. Well, we don't know angle N, Bo.
My angle N.
Angle N is angle 7. Uh-oh. Morty, go. 6 is not a remote interior angle. I don't care. Listen to me. Angle 1 has to be greater than this and greater than this. 6, I don't even know what that is. No.
Mr. Stroud,
Tell me.
what if you erase the top half, so then you only had like triangle OQP, and then 6 would be on, wouldn't it?
Then 6, I agree. Angle 6 is less than angle 1 plus angle 2. Angle 6 would have to be this angle. True, guys? Harris, did you learn something today?
Yeah.
All right, I know. Agony of defeat. I wish I could say I knew what that tasted like. All right. What? Angle, let me draw this for you. This is angle P. Angle P is the remote interior. What about?
Angle 7.
Exactly, and angle 7, like, no, like.
Angle 7 is already.
But you already said 4 and 5.
7 is this monster N right here. If you would say PNO, I'm okay with that. You can't just say N. Can it say NPO? Who's talking to me like that? NPO is angle P. No, because angle P can only be drawn with. All right, we need to move on. Shh, hold up, I got a few minutes here. All right, here we go. Let me erase all this. All right, that was embarrassing. Measures that are greater than angle 4.
7, 8. No, it's not angle 1. It's angle 4.
Whoa, 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 whoa. Hold on. Hold up, Brady. Brady wants to embarrass himself. Go for it. Measures greater than angle 4. I'm going to say what I'm going to write what you said. Angle 7.
8.
Angle 8.
Angle O.
And angle what?
Oh.
Oh.
No. N-O-P.
Wow. N-O-P. Nope. That's probably what I'm going to end up saying. I have no idea what he's thinking. None. All right.
About 1.
Oh, boy. Bo, let's go. Go ahead. Bo knows. Bo, go.
Angle 1.
All right, hold up. Let me start with angle 4. Here's angle 4. Yes, I like Bo. He finally got something right. Angle 1.
Look on me up.
All right, here we go.
So then we got 8.
Angle 8. Okay, I like that. I like that. Angle 8 is definitely greater than angle 4. Now, for those of you guys like, I don't understand that, angle 8 has to be greater than these two angles. Shh, 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 shh. All right, so far, Bo's 2 for 2. What else? What else?
On angle 6.
Who's jumping in on that one?
Me again.
All right. Here we go. Here we go.
And then we got 1. Oh yeah, I already said that. Yeah, it is good.
All right.
4. I don't know. 7, 2.
Well, definitely.
7.
Well, we know angle 4. If we had to, we know it's got to be less than NPR. It's got to be less than NPR. Wait a minute. I'm sorry, NPO. Shh, hold on. NPO. Oh, that's true. Be consistent. Be consistent. All right. So now, I'm not sure if I can see anything else.
Oh, no.
Yeah, that's why we're not here.
Actually, yes. You learn that. Sit down, please. You're making no sense as usual. Go. Shh.
How is it 1 and 8?
What?
So, since you talk about exterior angle, any angle inside the triangle, any way it is, it can't be greater than less.
Right. Okay. Now we got to move on because I'm going to run out of time here. All right. Now the next thing is I want to show you something super duper easy also. All right. When you on the next one, it's very easy. All right. So I want to show you something. So I don't understand why this is trouble. So please look up on the board. All right. This and this is an angle. Now, if I'm going to erase this, but what I'm going to do is I'm going to try to keep this piece the same. All right, so you got to watch me. All right, I'm going to create an angle. All right, so as I'm creating the angle, and this is getting bigger, all right, when I stop, that creates a triangle. So please just listen. It's super easy, and every year people mess this up. All right, and like I said, I don't understand the difficulty. Now, this side right here is dependent upon what? What angle? Yes. Listen, I think that's just so obvious. Right, so I'm going to say that again, and you watch. All right, what I'm doing is I'm creating an angle. And as I create the angle, right, the thing that's affecting the triangle, this opposite side is dependent upon this angle. The bigger I make the angle, the bigger what? The what side, though? We say the opposite side. The bigger the opposite side. The smaller you make the angle, what? The smaller the side. So now how does that apply to this right here? So look, if this length is 6, that means this angle out of all 3 of those angles is what? The smallest. All right. Now, again, I don't understand the difficulty there, but for some reason, kids mess it up all the time, right? The opposite side is related to the angle, all right? So because this right here, listen, just be quiet. Let me finish now. Stop interrupting. RT is the largest side of the triangle. that forces angle what? Angle S to be the largest. All right, that forces angle S to be the largest. So again, in a triangle, and this only works for a triangle, opposite the largest side is the largest angle. And opposite the largest angle is the what? Largest side. All right, so the middle side is the middle angle. The smallest side is the smallest angle. And again, I tried to demonstrate what I mean by when you open up an angle, the larger you open up the angle, the bigger that side is created. All right, so now with that information, let's look here at number 1. So what would be the largest? List the angles from small to large. So the smallest would be what? Angle T. And then what? Angle R. And then what? Yeah, again, guys, super duper easy. Super easy. All right, so now we're going to go with smallest side, SR, and then ST, and then RT. Now, again, I'm saying that's obvious. All right? And like I said, for some reason, kids blow this every year. What? Yes, because what is given? That is exactly correct. So question number 4, let's go with the angle. So we'd say angle. Wait a minute, I'm on the wrong one. Oh, yeah. Here we go. So angle what? No. Come on. Ask a question. What's the matter? We did 2 just a second ago. All right. All right. Here we go. Number 4. Yep. So we'd have angle what? S, U. I told you, very simple. And then number 5. Here we go. Angle B, angle C, angle A. No, it's really easy. Okay, so I'm totally comfortable with that. So now I have recorded a lot today. So you got, please listen. Again, I don't think it's hard, but I'm just telling you from my experience that kids make mistakes on these every single time. And I keep telling the people that make the mistakes are the one that are like, oh, that was so easy. There's no reason for me to do the work. I'm just telling you, is everybody hearing me? Right? If you don't do the problems, right, then you're going to make a mistake. All right. Now, I really should post the solutions. All right. So if I don't post the solutions, someone needs to send me a note. Say, don't forget the solutions, because I want you to check all the answers. All right. I want you to check all of the answers with both worksheets. Honestly, it's a 5-minute, maybe 10 minutes for a worksheet. It's really simple, but I'm just trying to tell you guys, if you want to do well, you got to do the problems, right? It's simple. I promise you, if you do the work. All right. Geometry for the rest of the year, we're not doing as much proofs. All right. It's all just about information and recalling information. Go. Yeah. Here we go. On this one. Oh, yeah. So again, the angles of a triangle add up to what? So you have to just do 180 minus these 2. All right. Which is going to be 66, I think. Right. And now you can tell. All right. So there you go. Let me go ahead and pause, and I'm going to try to post the solutions. I got 3 minutes. You guys, thanks for a great day, my homeschool peeps. All right. Have a good job or have a good day. All right. I'll see you tomorrow.
Thank you. Bye.
All right, guys, good job.
Goodbye. Wait, do we finish it?